Hello, grade 7s. Welcome to math for today. We're going to be doing the area of triangles and parallelograms. So we've already done both of those separately, and now we're going to compare the two. And I just want to point out for today, I have Sarwat's name and Wyatt's name. Good job doing your homework on Thursday, as well as many other people. So keep doing your homework and you might see your name up here. And Sarwat's onto her second sticker here, so good job. Okay, so just a quick lesson today and a quick little bit of homework. So, area of triangles and parallelograms. So let's look at triangle A here. And parallelogram B was made by making two copies of triangle A. So one in the same form and the other triangle was flipped upside down, and this formed a parallelogram. So let's think back. How do you find the area of a parallelogram? So we learned that you can't just find the length times the width as you would with a square or a rectangle, because, for example, you could have another parallelogram with the same length and width, but a much smaller area. For example, if it was like this, that's roughly the same length of the sides, but the area inside is much smaller than this one. So you can't use length times width, but we found out that you could use the base times the height. Okay, so parallelogram area is base times height. So knowing that you can find the area of the parallelogram by the base times the height, how could we find the area of this triangle? How do these two things relate? Well, this parallelogram, remember, is made up of two copies of this triangle. So whatever this area is twice as much as this area, right? Because this is made up of two triangles the same as this one. So this whole area is twice as much as this one. So what does that mean for our formula? So a formula is really useful. Instead of having to look at each individual shape and try to figure out what the area is, it's really nice knowing what our rule is for that. So if we know that the area of a parallelogram is base times height, well, the area of a triangle must be half of that. So we could say the area of a triangle is base times height divided by 2. So whatever it would be, so the base times the height divided by 2. Okay, so that's really, really useful. So you can look through the questions on your page in your books. We're on page 175, and it's showing you again how that works. That's just kind of proving this to you, and you can look through those if you would like, or you can take this formula and you can try the questions out in number 5. So page 175, number 5. So that's your only homework, is that one question. So there's 4 base and height of triangles, and you can find that out using the formula. Now before I let you go, I'll just practice a couple with you so you can see what that looks like. So So let's just say we have a triangle, and the base is 10 centimeters and the height is, let's say, 10 centimeters as well. Okay, so let's say it looks like this. It's 10 by 10. So what we'll say is the area equals base times the height divided by 2. So we'll plug those numbers into our equation. So base is 10, height is 10, divided by 2. So we'll multiply first and then we'll divide by 2. So 10 times 10 is 100, divided by 2, 50. So the area of this triangle would be 50 centimeters. Okay, let's try one more. Say triangle was, base was 5 and the height was would say the area is 5 times 8 divided by 2, because it's base times height divided by 2. And then we would have 40 divided by 2, which is 20. So the area would be 20 centimeters squared. So hope that makes sense. So you can look through it and try to make sense of why that is, if you'd like to do that. And you can also just take that formula and just trust the mathematicians who figured this out for you and use that to do number 5 on page 175. Thanks.